Hello, today we're going to be solving problems, and we have come to a type of problem where our problems will involve chemical equations. Then in this case, there is a certain strategy how to solve such problems. So I suggest that we solve the following problem. We are given an equation for the combustion of the organic substance ethanol. Ethanol is an alcohol that, like almost any organic substance, can burn. When it burns completely, it produces carbon dioxide. This is valency 4 carbon monoxide or carbon dioxide, and water is formed. The combustion reaction always takes place in the presence of oxygen. Now, how are we going to solve the problems, and what do we know? Note that according to the condition of our task, we are given the mass of ethyl alcohol at P 92 grams. What are we being asked to find? We are asked to find the amount of substance involved, oxygen. Then we must find the volume of carbon dioxide under normal conditions, and also find the mass of the resulting substance, water. So how are we going to solve this? Note that by the condition of our problem, we are given ethanol. Let's underline it with a line. And oxygen is unknown to us. He's being asked about. We will emphasize it with 2 lines. Then carbon dioxide, also with 2 lines. And the formula for water will underline it with 2 lines. Now from the bottom, since we're going to solve with you through the so-called mole method, let's underline our known moles under these substances through the equation. So for ethanol, it's 1 mole. For oxygen, it's 3 moles. And for carbon dioxide, it's 2 moles. For water, it would be 3 moles. Where do these numbers come from? Obviously from the coefficients in front of the formula. Now, moving on, we know the mass of our substance ethanol. The first thing we have to do is to convert the data of our problem, if they are not given in moles, into moles. Then, accordingly, we can find the moles of C2H3OH through the formula, the mass divided by the mole mass. So it will be 92 grams, and we can find the painter's mass through the periodic table. To do that, let's remember that carbon weighs 12. That's 2, then hydrogen is 1, it's 5. Oxygen 16. And then hydrogen 1, that's 1. And then we have a total mass of 46 grams in terms of moles. And then the grams will be reduced. And by the terms of our problem, we're given 2 moles of ethanol. Let's sign these 2 moles above the ethanol. Then oxygen, respectively, will be X1 moles. For CO2, it will be X2 mole. For water, it will be X3 mole. Next, we need to find how many moles there are of each of the substances according to the condition of our problem. This follows from the usual proportions that you can see in front of you. And so for oxygen, the number of moles of oxygen we find, mind you, 2 moles to 1 mole as X1 to 3 moles. And then for oxygen, this number of moles will be respectively 6. Next, for carbon dioxide. For carbon dioxide, we find the number of moles also through the proportion of 2 moles to 1 mole as X2 respectively to 2 moles. And then we have 4 moles of carbon dioxide. Next, for water. Accordingly, we find moles of water also through the proportion of 2 moles to 1 mole as X3 to 3. And accordingly, in this case also we have 6 moles of water. That's it. We have found the found moles. Now next, let's see what was asked of us in the first place. Look, we had to find the oxygen moles. That's exactly what we found. That's our answer, but for oxygen. And now we need to find the volume for CO2. And then next we need to convert the moles respectively of CO2 that we just found into volume. In order to do that, we need to use the formula. Vm, the molar volume, we multiply by the number of moles of CO2. Okay, let's do the substitution. The molar volume under normal conditions for all gases is 22.4 liters with respect to moles, and multiplied by 4 moles. Accordingly, mole and mole are reduced and we get all. Our answer for CO2 is found. Here we have found the answer we needed for carbon dioxide. Now let's find the mass of water. In order to find the mass of water, we have to use the formula. The molar mass of water multiplied by the moles of water. The molar mass is exactly the mass of water, and since the molar mass is not the same for substances, accordingly, it will need to be calculated. And then it turns out the mass of water, hydrogen is 1, oxygen is 16, the hydrogen, let's not forget to multiply by 2, so that's 18 grams to moles, and multiplied by 6 moles. Yeah, the mole and moles are reduced, and then we get 108 grams in the answer. That's it. Our answer is found. Thus, we were asked the terms of the problem, we were given, respectively, ethanol, and asked the moles of oxygen, the volume of CO2, and the mass for water. Through moles, such problems are solved very quickly, and it is not necessary to write down the proportions, because the proportions can be easily seen from the scheme of the chemical reaction itself, and the calculation of such, as a rule, does not require large complex calculations. Well, and then we calculated what was required in our problem and got the given answers. Goodbye.